inspect the front panel a little bit. So if you check eBay, on Saturday, yes. Okay. 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 Hello. Welcome to Fun Project Monday on Saturday. Yes, we don't make it on Monday. Never ever. The day of a live stream where we design an electronic product just for fun. No deadlines, only delicious beverages. Yes, I have coffee. So, in the last streams, I had some really unpleasant experiences with the German package service, the yellow one, and I didn't have my PC for a long time, so there was some delay in me providing the streams. But today I want to go further with the project itself. We are still not doing hardcore PCB design or soldering something. We are far away from that. And today I thought it would be a good idea. It would be a good idea if I would have turned on my microphone. Yes, it's Fun Project Monday on Saturday. Now with a working microphone, but the coffee was still delicious. One thing we had done so far, or didn't done so far, we did some outlining of a project we want to do. We decided what we want to do. So an LED controller. We've done some how do you call it? We've done some basic narrowing down of devices we want to use, of power supply we want to use, and so on and so on and so on. And that's pretty good. Now I want to move a big step in the right direction to completion of a project. And because we already thought about power supply and the power circuitry, that's pretty good. We're going to take a look on the case itself, on what's on the available cases on the market, at least here in Europe or in Germany. And we're going to do some considerations on designing the front panel and how to build it and how much it will constrain our device itself. So let's start by taking a look on cases. And as we have already decided, I did some preparation. I just have to open something. So I'll change to the browser. And I will first draw what I mean. I will first draw a little bit. Drawing is always fun. I need to change my setup. So now I can see everything better. Okay, we want to draw what the actual problem is. So I have decided, or we have decided, that we want to build an LED controller with, let's say, kind of tilted case. We'll look around that. If it has this part on the corner, who cares? But it will be some kind of case with an angled front. That's always pretty neat. And what I want to try out, because I didn't have done this before, I want to do a front panel PCB. I want to do a front panel, and I will add a PCB behind that panel to do the where I will mount the buttons. So if this will be our cut through our enclosure, it would look like that on the bottom. There are the standoffs which are almost always available on such enclosures. We will have there a PCB where all the power electronics lie. So everything that produces a lot of heat will have the option of convecting and of cooling itself down. Then we will add our front panel, make it a little bit thicker. So this will be our front panel with all the buttons and whatnot. I will draw it differently. We'll draw our front panel like this, and a bit different. So like this, and this. And we'll have a PCB with some kind of standoffs. I just realized standoffs are extremely expensive. Or they have gotten extremely expensive. I never had to buy many of those. And behind that front panel, I will keep the colors. We don't need straight lines. Straight lines don't matter. And behind that, we'll have our PCB, where the buttons and the knobs will stick through, like that or like that. We didn't specify this before, but the buttons and whatnot, they don't have to be of high quality. That doesn't matter really. Of course, we could use real switches like those in a keyboard. Those keyboard switches are, of course, great. And I would have even some on stock, but another location. As you notice, we had another location. The postage service did fuck up quite a bit, so I was a few weeks no live stream, or 2 weeks, doesn't matter. So, and we'll do this. We'll have our first, and between here and here will be some connector. And if we build it like this, there is one very critical space. That is this one. Because most cases don't give you the easy way to specify this length. Of course, you only use sinus or cosinus, angle, no problem. But this height can be critical, especially if you would have been using some sort of bigger connectors. For example, you have I once had a project where I had this arrangements where we have big front panel stuff, and that can be quite critical if you have densely built your device. But I think we will be fine because we don't have really big devices. We almost can do everything on PCB. We most certainly do everything in SMD. We will do everything SMD, but not the front panel. The front panel will certainly be through-hole technology because there is no need to do SMD. Maybe a multiplex or something, but that doesn't matter. So we're going to take a look on the market of front panels now, or not front panels. The market on another point, yes. LEDs. What I thought to do. I will do the following. Actually, that's a point where I want to use SMD on the front panel. I want to put on the LEDs. The LEDs, the indicator lights, they will be placed on the front panel PCB. Of course, they will be. And the front panel itself, so the front panel will have no electric stuff. We have some sort of cutout or some sort of transparent material at that stage. That now sounds pretty complicated and everything, but it actually isn't complicated at all. Because you can play around with the copper. Because if you would use an PCB for the front panel, which I certainly do because designing PCBs is okay. I don't need to go to any other program than my EDA package. That is certainly easier than doing something different. It simply is. Okay. So now we can take a look on the market of enclosures and find out what's working or not. Of course, I'm always somehow prepared for the live streams. Otherwise, it feels pretty awkward. And for that, I'll show you how I found how I think you can get a pretty good impression of the market for enclosures. So let me change the. So yeah. That's what I want. Next up, you go on Google, you search for enclosures or the specific kind of enclosures, and then you go on shopping. For example, in Germany, for the enclosure, I will use a German supplier. I will tell you why in a second. Research für Bultgehäuse. And go on shopping. And now you get a pretty good overview of nearly every supplier and at least get a feeling of what's available and the price range it is. In preparation, I first searched the suppliers themselves. And of course, Bobbler, Teco, Hammond, Manufacturing was another one. Nobody that comes to mind currently. And we see there are different kinds of Pultgehäuse, of angled enclosures. First of all, we got these very slick ones, of course, obviously designed for battery enclosures. These are also available in a little bit different form, but unfortunately they don't have by themselves front panel. I would use these if I had a customer who asked me, hey, I want to have a foil display. It's very easy. You call them, you search for a supplier for foil displays, you give them the manufacturing data, and then you can simply glue that in. Because that front panel, that doesn't work by itself. So the whole front part is a part. The whole front cover is a part. We don't want to use this. This sounds like too much work. And it's not efficiently. Of course, these are heavily expensive. I don't want to use these. And then we got enclosures with, that's not the right one. Then we got one, these are fully metal or have bigger metal parts. That would be one. This one from Hammond Electronics, which gets in the right direction. That's okay. We could use those. And of course, we have a lot of aluminium parts. That's of course is very expensive. And of course, not the front panel by itself. That's unfortunate. And we have those Teco enclosures. That are the ones I have originally thought about using, because they seem appropriate. Of course, this is, again, very expensive. Don't want to use it. Curved. Great for foil, but not for what I want to do. And so on. That's, of course, complete overkill. And. That could be an option, but it's not the right form factor because you don't need so much space behind. Maybe after we've done heat calculations and heat convection calculations, of course, something very appreciative to do. We'll find out that we need more space for convection or maybe even venting. Yeah, but who cares? And beside that one Hammond enclosure, we can see that the market is not as, let's say, does not have as much to offer. Like that could be something that goes in the right direction, but having two different panels, that's too much. That's too much. Yeah, not tilted. Quite too expensive. Of course, it's RS, so of course it's expensive. Yes. And as far as we go, yeah, that's Teco. What I wanted to use. And we mostly found everything that the market can supply us. Yep. That's almost exactly what I designed, what I drawn. That's of course unbelievably expensive. And we've got a pretty good, unbelievably expensive. and we got a good impression of the market. One thing I've invested a lot of time in is find enclosures by Chinese suppliers directly. They don't produce it. You don't get it. AliExpress is empty. On Alibaba, I didn't find anything. On Alibaba, I didn't search that thoroughly, but Banggood either, no, nothing to find. You simply don't get it. Nothing you can do. Yeah. So yeah, that wasn't really what we searched for, so we can put that away. Actually, this Hammond part could be an option. Let's take a look at Faulkner. Faulkner is actually a pretty price reasonable supplier, because if you order something at Faulkner, it's the same as a different, very big electronics distributor in Germany. You also got the same order numbers, but at Faulkner it's way more cheaper. So let's compare those. And the other I found was such a Teco enclosure. What's that? Okay. And I want to get a data sheet to see if there is a bigger difference between those. Which size we use is not that important at that point in time. Because we will start building the front panel or designing the front panel and designing the power supply circuitry. And then we see which kind of size we will have to work with. Because this is a fun project, we don't have to do so much cramming in and so much try-harding to let our electronics fit. We build something nice. Okay. One minor annoyance with most of these cases, they have such PCB holders inside them. That's very unappreciative if you want to add some kind of connectors to the back. You normally oh, I see something. Okay. Yeah, okay, it works. Normally you think about having a flat surface to add your parts to, because a flat surface is something very appreciative. With the Teco enclosure, I searched in advance, if I remember correctly. You get those too, but you get way less. So at this device or this enclosure, it gives at least the impression, let me check something. It at least gives you the impression that we are okay with you putting some connectors in. You don't have to grind the whole back of your part. That's something really appreciative, but that's one kind of closure I want to use. Let's talk a little bit about the kind of service Teco, I don't know, 362 series. I'm not quite sure. Let's take a look how they are numbered. Of course, I already prepared that. Because I have actually no real overview of the Teco market itself. These are pretty nice because you get a clear, transparent overview, or clear, transparent cover extra, so you can have a these ones. I will open them. These come with an extra transparent top part. So here you are able to build, how do you call it? To build some sort of PCB in, and it's secured. Or you let it open. You can do. It gives a lot of opportunities. That's a great enclosure. I like it. So there's most probably this. Okay, I think these Europoled enclosures are made for Eurocards. So 110 times 160 millimeter PCBs. Yep, they are. Okay. We don't need to have this specific dimensions. That's not important. But most probably it will be one of these because they are more wider. And our design and our application screens, they have a wide case, so you have space for all your buttons, and that's something really appreciative. Okay, let's go further. Let me change the interface again. Let's drink something more. I even prepared myself some tea. I already had enough coffee for today. Never thought I would say this. Good. The next part would be to find out. The next part would be to find a very basic constraint we have is here, because is in this area, because this part here, so the rotary switch that we're going to use, or encoder, we will build it in to change the RGB values. Very basic idea. Okay. But using this kind of arrangement, we need to make sure that the buttons, so we have this height by the rotary encoder, and we want to make sure that these buttons here, because normally they look, because these, if you drive them nicely, yeah, if you draw them nicely, they look somehow like that. And you have some sort of, yeah, we don't need to use S&D, but they look somehow like that. And we need to make sure that this height here, that this button is able to stick out of a PCB. So I have found this correlation. And based on that height, we can make out how, what kind of, how do you call that? What kind of LEDs we need to use. So how they spread the lights, the angle. What kind of angled? No, that's not the right word. Yeah, we can choose the right spot angle for the LED. Yes. No idea how you call it in English. I will not look it up. Yeah, to prevent the LEDs to shining on multiple indicator areas. So let's work on that. Let's change. So the problem with part sourcing is, no, don't want that, or I want that. The big problem with part sourcing is that unfortunately most gets manufactured in China, and people here in Europe or America or wherever, they buy the part in and rebrand them and sell it expensive. RS does that, everybody does that. I would do it myself. because we are not competitive enough we don't have a right where are the cents too cheap. We could produce them too. That would be really good for it would be really good for us if we can produce such basic parts by ourselves. We don't really do it, and if we do it, it's ridiculously expensive. We can do a comparison later. I think that would be fun. Comparing the kind of prices you get sourced directly from China and comparing the prices you pay at a German distributor. It's amazing. So, of course, everything gets built in China, so we use LCSC. And we need to check two different parameters. We need to first find a rotary encoder, and from that we find the right switch and the right kind of LED we want to use. Of course, we also could use backfiring LEDs on the front panel, but these will produce a relatively small indicator. We build something nice so the indicator lights can be big and flashy. And we have fun with that. And we would need another cable to transfer the data. Of course, you could say we have the they call it spacers. They are all metal. We can do power delivery and data delivery by data. 4 screws, great. We don't need more. Yeah, but no. I don't want to have any voltages on the panel, and it's not really needed. So we will let the panel stand alone without any electronic circuitry on it, and use the panel under to find the right part. So let's simply take a look. Of course, on such a site like LCSC and AliExpress and Alibaba, you will find a lot of manufacturers who build too cheaply. It's built not to a good quality. So if you search by price, I think that was already put in correctly. $4,000 for an yeah. Okay. But I don't want to have such big. First, I want to have them in stock. Oh, what's that? Oh, that are smaller parts for under a cent. They're not really interested. Not really interested in those. Are we in the right? Oh, we are not in the right panel. Rotary encoders here. The price is set up correctly, yes. So, of course, there are also some quite small ones. We don't care about those. And we will go simply by the picture to find the right one. Because we want to stay in the relatively cheap area, but we don't want to skim too much. So that actually could be a part that we're going to use. But it looks, the shaft looks too small. Size matters in that case. That could be a part because the shaft is long enough so it protrudes a bit, that's okay. That could be an option. We have a burns part. And it's cheap. Okay, let's take a look on that. Don't want another for window. And take service. Alpine company producer is very present in that area here. And burns, that's something I didn't expect it. Okay. That's actually also a very nice part too, because the base part is not as thick and the top part is still able to still protrudes it a little bit. That's actually a very nice part. From a picture, I don't know if it's the right one, but I think they done their job at LCSC good. Why shouldn't they? Let's take a look. Yeah, very special. That could also be an option. I'm thinking, do we have some sort of option to limit our the angle it rotates? That actually would be a good idea. There's something for that. But let's check the data sheets. We take a look at enough parts. And to check if they are latching or not. Because for such a dial, you don't really need an, how do you call it, an indent on the different parts. You're pretty happy with, check something. You're pretty happy with having non-indent roticoder. Let's take a look on the datasheet. Okay. It's built for microscopic current circuits. Okay. Let's only use microscopic currents. There are mechanical drawings. Mechanical drawings. Everything's electrical. Unfortunately, it's... Nope, no idea. Yeah. That's really unfortunate. And it's in... Please tell me it's in millimeters. Yeah, it is in millimeters. That would be good option, I think, because we have 50 millimeters. 50 millimeters, not too much. Ah, well, it's allowed to be 50 millimeters because it still needs to protrude the front panel. Yeah. Wouldn't see why we can't use that part, but I want to see if those are indented or not. Okay. Let's take a look. The dent position will be... Okay, it says it's dented. 24 pulses per 360, okay. Sliding noise bounce. Okay, no formation, no. We got some soldering instruction, that's okay. Yeah, no real information, unfortunately. Or nothing I found. No description. And these... I think that's the same, or effectively the same with... Oh no, it says completely different data sheets. Okay, and now we're information on the type of dent. No. Take a look here. Maybe the burns part has a better description of the actual part. Oh, no dents. Here it is. Okay, so the other part will certainly have dents. And this part, the second digit. Second digit. It is dented, unfortunately, with 12 dents. The other part has 24 dents, which is a bit better. And the shaft length, okay, you get 25 to, do we have here. FS, what kind of device is that? FN. 4FN. 4FL. We have these dimensions. And we see that it is L1. Okay, it's 50 millimeters. We could use a screw on the front panel. Yes, some more stability. Why not? Something is not really required. F7 millimeters, okay. And LB is 5 and that R 6,5. Okay. So we will probably need to have at least so we have this dimension here, and we see that this dimension, which is critical for us because that's the dimension from the bottom where the part lays on the PCB till the end. So this point, that's the minimum height requirement we need for switches. Or that's the minimum height requirement that we need to space our front panel. So we can expect to have 7 millimeters, 7 to 8 millimeters of space, because we do get a washer. Yeah, we don't want to exceed the 6.5 millimeters. So we most probably have total distance from PCB to front panel, to front side of the front panel of 8.1 millimeters, because we have 1.6 millimeters PCBs, 1.6 millimeter PCB, plus the length of the encoder, and that's the and that would be a good idea to have as little space as possible. So we will have about 7 millimeters with this part. Okay. Do these parts bring any? Okay, it's the same manufacturer and another datasheet design. That's great. I like that. I like that a lot. Yeah. Okay, that would most probably be too big. Oh yeah, that would be too big. We don't need to look at this further. But I think we're going to use that burns part. It's relatively cheap. We can afford this. But we even can get that with more indents and maybe a push button. That's the nice thing about such a naming scheme, is that we immediately can find all the other data that we want. So let's take a look. 24 indents. I think a finer indent would be very nice, or no indent. So we need to change the second digit and use an S. Oh, with S we get another spacing, right? N PC4F as, yeah, with a spacing, it's getting, with a push button, it's getting way bigger. So maybe we do it without. Well, let's check the prices. So if we would only change that digits, we'd get a finer indent burns part. Maybe see. Okay, we don't have it in stock. Let's do a sanity check. Can we get it like this again? Yeah, it works. Let's see if we can get it without indent. Nope. It looks like it's the only burns part they supply. Or based on that, the only burns part they supply. Okay, no chance. No chance. Maybe let's take another look at the more, let's say, the more sophisticated datasheet we found here. That one. Maybe you can get something useful and find useful part out of that. Short shaft type, through shaft type. And find something with a lot of indents. Let's stick with the, if you take a look, it doesn't matter what kind of shaft we use. You can also save us a screw. Makes a screw, that's okay. Having that extra mechanical resilience like the burns part would have been something nice, but it's not really necessary. And let's take a look. That's okay, 5mm. Do we have some hints on how the model number is constructed? 12mm. Okay, my Chinese is not up to par. Yes. So effectively we have this EC12E series that we could use pretty good for our device. But unfortunately no real hint. Here we go. EC12E 42. What's that? What's that sign? Is it indentless? Is it smooth? What does it mean? I have no idea. Help me. Is it traditional or easy Chinese? Let's try easy one. Vu. Keiner. Okay, so we have a part that doesn't need without indent. That's actually pretty nice. That is pretty nice. So heavy. That could be a part that could make us happy. But it has a long shaft. Maybe get one with a smaller shaft. Now that's all through shaft, No, we don't only get that with 12. Okay. Let's take a look. Oh no, that's 20mm. That's okay. We can work with that. Okay, let's see if we got this part on LCC. Wow, we also got it. Unbelievable, we even got the screw together. That's nice. Do you get an... Okay, you want to get that over your data sheet. They don't have a switch. No, they don't. No, they don't have a switch at all. Okay, no problem. That's definitely a part we want to save us. Maybe you can find that part with a push button switch. Yeah, we see. Now it gets already more expensive. Unfortunately, but yeah, that's how it is. Well, at least we found with the cheaper part, the right part we want to find. So without an indent, and then we can... Yeah, that's nicer. Having no indent. Okay, let's take a... Let's see if we get this with an... Let's see if we can get this with an... Within switch, within push switch. Let's stay at Alpsaline and rotary encoders. Maybe they have some with switches. Let's take a look. One remaining. Okay. Unfortunately, they have no real search function. That is that's a bummer. Let's see if we find a part number which is completely different from what we have. Like, we don't got that N in the data sheet, didn't we? No, we don't. But this one won't have a... This one could have one. Let's take a look. Let's take a look, but how expensive are those? Yeah, 244. Now we get in the more interesting, the more higher price range. Full metal. Oh no, they are dummies. Mount surface. Okay, you can get them as surface mount. That's nice. Oh my god. I'm going to try something. Let's see if Google Translator can make my life easier. So camera. So let's take a look if it makes easier for us. Ich hätte gern Chinesisch. Vereinfacht. Runterladen. So, okay, let's try that. Oh shit, that works. So, yeah, we have an bad schalter. Oh, that's great. Because of the camera, I can get an instant translation. That's great. So that's schalter, and we have this one which is called no, and this is called lift up. I only lift up and don't want to lift it up, but I think the series is too expensive. So let's see if there are cheaper ones with a few more pins. ECE 12. Let's take a look. No, they don't certainly. Nope. Nope. They could have some, but they're expensive too. they could have it's worth. No, we already looked at those. They don't have a push button. Nope, not the right form factor. These are. Nope. That didn't look right at all. Let's take a further look here. $170, yeah, that's a bit better. €5. Never ever. Nope. Yeah, they are too big. That could not too expensive. Not the right series. In worst case, we simply leave it out. That's not a big point. Maybe you can find some nicer parts. Nope. Everything too expensive. I don't care about those. They could be EC11L. Didn't take. Oh, that could be. Let's take a look on that data sheet. EC11. Okay. That's the standard stuff they wrote. So I think that's a really interesting mounting. Like, you should mount the front panel embedded inside the rotary encoder. Yes, we will do this. Very interesting. Let's see if I have a DE. What's D and what's E? Switch circuit diagram. Perfect, we have a switch for. I have a switch for in Euro. That's great. We're going to use that one. Do we have indents? That's the next point. Do we have indents? Let's see if I put it in here. To be honest, I would rather have indents and rather use indents there rather than have no switch at all. Okay. 30 dents. Number of position and detents. That's great. 30, that's better than 24. That's good. We're going to use this. Oh, that's hot. Good. I should use this. This is much more appreciative. Okay, I think we found our part. Okay, let's take a look on this, on the height of that part, because then we go very quickly through that and that. So, stroke. Oh, I don't enjoy this at all. Oh shit. Like, do they mean that's 4.5 and that's 7? So that's 24. Okay. So that goes inside. So 45. 4.5 millimeters. And 7. Okay, that's actually even a bit smaller. So we have. Yeah, will most probably be around 10 millimeters. So we will have this shaft protruding through the outside of front panel with those features. So we have a good fit inside the front panel. We will do this. Yes, we will do this. Okay. Yeah, everything looks good. Yeah. Nothing I can... Yep, we're going to use this. That's saved. Okay, after we have gone through the odyssey of searching for a good part, I need to check something. Okay. We search for other stuff. We need to take a look on an appropriate push button. I think I have already prepared that. Let's take a look. Boxes, no chance. Here, one of those cases, 70 euros. Most certainly. I will buy that. I would buy that if someone will just pay for this, no problem. But that's not the position I stand on for this project. So, let's take a look on... nope. Tactile switches, that should be the right one, shouldn't it be? Yeah. So, here we'll search for tactile switches. So, we will draw that. We'll do a small drawing so we don't fuck that up. Let me change this. Only tablets. Yes. You're allowed to see my face explaining everything. That's nicer. So, what we have done, we found this rotary encoder. So, let's make a sketch. So we will have this. That will be our front plate. Draw it like that. And prepare this. Good. And we have our piece as a front plate. And I will change that. So it is not really about doing to scale sketch here. That's not proper. We work with the numbers. So we have our part here. Our encoder will look something like that and has a shaft that looks like that. And from that bigger shaft, our cap and so on, but that's not important. We don't care about this. So besides that, we will have a normal tactile switch that will produce... Yes, that's... Nope. We'll have a tactile switch. That switch will look something like that. So let's check back with the datasheet. Let's check back. That was one we wanted to use. Yes. Was it 4.5 and 7? Yeah. So we will have change back. So we'll have here a 4.5. That's not good. I'll do it a little bit nicer. So, with here 4.5 millimeters. We'll have here 7. And from here we'll have 1.6. The most important fact out of that is that we will have 4.5 plus 7, that's 11.5 minus 1.6, around 9 millimeters. So that will be... So 1.5 11.5. Then we have 10.7 and -1, 9.7 millimeters. Oh, we don't need to specify that. So we need to make sure that this button is, we need to make sure that this is high enough. So we can still push our button. Good. Let's search for a button that is in compliance with this boundary condition. Let's take some more average. Okay, it's not hot enough. That's good. Not too hot. It is hot enough. Okay, let's take a look here. Tactile switches. Can we search for switch height? That's easy. So we want to have something which is higher than 10. We want to have it produce a few millimeters. 1 would be not enough. 2, 3, 4, 5. Let's search for 3 millimeters. Switch height. So we search for 9.5. Everything above. Yep, around 4 millimeters. And take all of them. 240 remaining, that's okay. Okay, seg width. Okay, let's see what we get. Okay. Okay. We can change an option for packaging. That doesn't help us. Width is not round button. We want a round one. We don't want to have squares. Squares are not easy to manufacture. And you want to have back nogging straight. I like my button straight. Okay, let's see. Let's take a look. Okay, they don't bother selling to us under 5 of quantities, that's okay. Okay, we don't want to have so much search results, because when we get too many ridiculous ones, so let's limit it to 2 millimeters. And we have as search results, that's good. Maybe we take higher quality ones and not the cheapest. $14.5. They don't. Yeah. Of course, these are nice because they have this big chunk of material, and above that is a plunger, so you don't get so much instability. That would be something to consider. Do I decide which parts are used by images? Yes. So let's take a look on the bigger ones, because I think that can be good for quality. 5 cents, yeah, we can spare that. A red one. Okay, let's take a look. Okay. That's something I didn't saw before. Okay, they did explosion drawing of their own product. Okay, that's of course reasonable. PCB welding drawing. Okay. So travel, it's very slow travel. How thick is it? 3.5 millimeters. Okay. 6 times 6. Yeah, part we could use. Very easy. Let's take a look. Maybe one thing we'll put some... Oh, I didn't have the right screen on, I just see. So, we are talking about switches. Okay, that's something I don't want. So, that's good. Okay. So, we have the different kinds of switches, and we really have... That could be a good idea. Yeah. They are available with 14 and 15 millimeters. Okay. Let's take a look on caps. Because if we're looking on that kind of switch, which seems a good option, because you have this bigger bottom part, we can take a look on caps. What cap options are available? Maybe in different colors. That's of course very nice. And how much area we need to put on the caps. They look good. Are there caps from that manufacturer, Yuandi? Let's take a look. Yuandi. I think they will provide caps for sure, don't they? No, they don't. Okay. So no caps from Gandhi. Of course, FPM really expensive. FPM is also resold by Reichelt. I think either a Chinese company or a German one. I don't know. Or a non-Chinese one. So let's take a look. They look good. Are they usable with 6x6 switches? That's the big question. So 13 millimeters in diameter, okay. For 3.8, 4.5. What does our big bottom part switch say? It says it has an upper diameter of... Oh, we have different upper diameters. 3.5 millimeters. Okay. So, for using these, that's okay. We will need... Oh. We need a lot of material. We need 5 millimeters for using those caps. That's of course a lot. 2.5, okay. Also, you certainly need more material, but that Yuandi part is also available with higher heights. So, for example, it doesn't matter. Actually, they look okay. They look really okay. I want to use them. If I want to use those caps with those switches, of course, we could do a longer market and part search, but there's not much to be gained. Really isn't. So I have 9.7 height. So that height plus how much is that? How much is that? That is certainly 4.5, more than 4.5. We need to put it down here. So imagine we would need 6 millimeters. Roughly 6 millimeters of switch, that's okay. So 6 millimeters of switch, so you get to 15.7 height. Question is here the height? Yeah, from bottom. There 8, that's okay. So this bottom part will fit under our we have a 9.7 millimeters height between the bottom and the higher part, between the top part of the front cover PCB and the bottom part of the front cover itself. That will certainly fit. Yep, we can use those. That looks pretty good. And we use those with A19. How much does TS A19 cost? That's A19. A19, that's okay. That looks good. That really looks good. We will save that. Save. Great. So, for us, we'll take a look on the PCBs. So, let me change again. Up. Yeah, I really need to stop this live stream. But I want to finish this, that's important, finish stuff. So, we want to choose an LED with the right angle. So we'll have, I'll use another color. I use pink, why not use pink? Who cares? So, this LED will have some sort of angle, it will emit the light. So we want to have an LED which, and depending on the kind of distance between the front cover and the front cover PCB, we need to specify what kind of angle we want. Because we get them in pretty different angles, and that's simple. You have triangle times 2. So how was it? I think it was sinus alpha times, that's x. No, then we want cosinus, don't we? We have cosinus alpha times that's alpha, then it's A and G. So F A through G. Yeah. And then cosinus through alpha, cos through R would be G. Cosinus through alpha would be. Do you want that? No, we search for G, yes. I put G through 1. So it's R through alpha is G cos. Okay, that should give us the right estimation. Let's take a look if we done it right. If don't have my calculator here, so we should have your favorite search engine. We have cosinus of a certain degree, let's say 30, times we have 9.7, and times 2 because we have 2, and we have 3 millimeters. Does that make sense? Maybe. So depending on the kind of LED we get, we'll need to use oh yeah, I didn't change that. So so we take the cosinus times, no, I want to divide it by, don't I? Yeah, I want to divide it. Now I don't know if it makes sense. 3 millimeters sounded like it would make sense. Nah, no. Does this make sense? No, it doesn't make sense at all. Is that even, is that even that? 90 is, oh no. 0.14. Okay, it's radiant. So it's P through how much? We said 30, for example. So P30, it's should be 2 is 180, 6 is 4 is 90, and 4 and 6, 360, 180, 90, 45. Let's do 45. Oh, that doesn't look good. What's happening? Okay. No, I talking too much. Too much concentration. I will do a break. And that break will be now. I will stop it now. I will do a break. See you. Oh my god, I was loose. So. Gonna 1-6. So I'm back. So I'm back. I just realized I'm streaming 1.5 hours. That's of course great if you want to do some maths, as simple as it is. So, but those 3 millimeters we got, oh, I got myself another calculator, checked it. That 5 millimeters sounds reasonable. So, that's big. Maybe we get narrow LEDs. Let's take a look on LEDs. I have no idea. That's the part I certainly did. Not prepared in advance. We want to have LEDs. That is certainly not the right stuff. Let's take a look. Ollie. Nixie tube LED driver. Functional modules, Nixie tube, LED display drivers. Nope, 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 nope. Infrared LEDs. Light emitting diodes. And I will change the display. Okay. No, not that one. This one. So let's check for light emitting diodes. I want to have a very narrow, Viewing angle. That's good. Everything smaller than 30 degrees. Let's see what we get. Not much. Let's see what is available. Package. Let's see. Let's take after the... Is that already filtered? Yeah, it is. Let's take a look on the pictures. Let's sort by price. Okay, the most cheapest ones and the most expensive ones are... No, the most cheapest ones are SMD. So, 50 colorless, transparent, positive, RGB. Yeah, we don't need RGB really. We need different colors. RGB would be a little bit overkill. Orange, red, blue. That looks good. They have a range of those available. Green. Yeah. So I have no idea how good this will work. That's something I'm simply going to try out. Yep. That looks okay. It's even a name brand, light on SMD LED. Let's check the datasheet if it's really what it's promised. And we'll see that we get angle. Oh, I can search that, that's great. Angle, viewing angle, 25 degrees. Note 2, figure 6. Take a look at that note. Note 2, Okay. That's certainly working with. Yeah, let's work with those light on parts. That could be okay. How big are they? Yeah, they're very reasonably big. That's okay. We're going to use those. I'll bookmark them, or at least bookmark the search result for that series. Certainly have some sort of series, don't they? They do. It's C90TPKT. That's a complete one. Yep. Let's take a look at the search results, which kind of it's that one, that LCD T. You want to use those. Let's see. And only two. Then we got more? Or are they now? Or is that another series? Oh no, also, come on. $25 degrees, not much remaining. It's okay. Take a look. Is that already filtered? Yeah, and we want to have light on, please. Let's stick with light on. 10 remaining. C93, is that also? Okay, it's seems like that's C9030 series. Yeah. Almost. C9, that's C9050. That is blue, 25, okay. There's a difference between C9030 and C9050, I want to know that. Was C9050 bigger? they are bigger, I want to have them. Because I do appreciate having it's easier to solder. I think they're smaller, aren't they? That's a C9030. We have 420 times 280. Those are smaller, we don't use them. We're going to use C9030 series, yes. C9030. Okay, yeah, that's a nice... Yeah, that's okay, we're going to use those. And check everything, and now, yeah, that's great. So, enough for today. I'm happy with what I've done, yes. So, the next stream, we will probably take a closer look on what kind of power regulator, or take a closer look on the power regulator design, thinking about the efficiency of a voltage range. We will reconsider the power supply circuit and the device or the microcontroller again, because I had some idea to change it. And yeah, we'll do this. Goodbye.